Hi, Michael here. Welcome to my channel. Hey, today I'm going to take a look at my latest eBay score, which is this TS-307/ARW military surplus dummy load. Now, a dummy load is not the world's most exciting device. If you don't know what it is, basically it's a fake antenna that you attach to a transmitter while you're testing it, and it converts the RF energy from the transmitter into heat. That way you don't break any laws while you're transmitting, check, check, check on the radio. And it also prevents you from burning out your transmitter, because if you transmit without an antenna, it's going to blow up. Here's the unit. It doesn't really have many markings. It's got a J stamped on there, and it's TS-307/ARW N33S70995. That looks like a serial number. And stamped in here we have a 17 CBUA. Not sure what that means. And stamped in the center, it's probably a bit hard to see. I'm going to see if I can get that focused up here. Might be able to take a look at that. Yeah, it's hard to see. There we go. We can almost see it with the camera. It says US and it's got an anchor. So I'm going to guess that's US Navy. So this looks like it is naval surplus. Hopefully it's surplus. Yeah, it looks like it must have been used to service radios in the US Navy at some point in time. Oh, it's an interesting little kit. There's a meter on the front. It's got a protective cover on there. Prevent it from breaking, I guess. On one side we've got our transmitter plug. It's a UHF plug, which to me suggests, obviously this is an older piece of equipment. UHF plug, nowadays I don't think a lot of radio equipment in the Navy is going to use this. They're going to use something a little bit better, but this is a common plug from, I guess, the 40s, 50s, 60s. So I'm going to guess it's that vintage, although it's in really good shape. So it might be newer than that. Who knows? If anyone knows anything about these units, please comment in the comments below, because that would be great to learn a bit more. Somebody's written OK there, so something's OK. We've got an adjustment here of some sort. It looks like a potentiometer probably there. I don't know what that does, but we'll pull this thing apart and see what's inside and hopefully be able to tell what's there. Now I know it's a dummy load because look, somebody wrote dummy load 50 ohms on the side of it. Funny thing is that on the eBay listing, they didn't show a picture of this side. So, that's kind of, typical eBay. Sometimes you get some strange stuff. I don't mind so much because what they also didn't show was this, which is a test set, what looks like a port. So what I'm hoping is that this is somewhere where I can sample the RF signals from, and that would make this a pretty sweet little find. The meter itself on the front here looks like it goes to 30 watts. So, it should dissipate around 30 watts safely, which is a little bit lower than I'd like, but that'll be fine for, CB work and whatnot. Okay, well, it's time to start taking this thing apart. So let's start by removing this cover on the meter. Let's see if I can do that. See if I can do this with one hand. Okay, we got it. I'm just curious. I guess this is just a protective cover. I'm just curious if the meter's mounted using these screws or not, or what. I probably, realistically, in the ham shack, don't need a protective cover on the front of this meter, so we can remove that safely. Hopefully not scratch it too badly while I'm doing this. The bad news is these things are just turning around in circles, so there must be a bolt inside somewhere holding that thing on. I'm going to leave that as is. Okay, well, let's take the case off here. I've got a slightly better screwdriver than I had for my last videos. Still not good. Need more subscribers so I can afford a real screwdriver. This one, it's a Craftsman, but you know, it's got this old school handle. Gotta get some of that modern stuff. Okay, let's pull this thing apart. And it looks like we got another one here. Another screw up top here. Okay. Oh. Now I kind of think these two ones are just mounted to something, I'm hoping. But the case itself is, if you take a look at it here, it is sort of a U shape bent around, you know, a frame. So I'm gonna pull screws off the bottom and hopefully it'll come apart. We've got another J marking there. I'm not sure what that is. Again, if you're an ex-Navy guy, US Navy, let me know. On the last screw here, and these are slot head screws, so this also, you know, says something about the age of the product, because I'm gonna guess that if it was 70s vintage, it would have been Phillips screws, you know, even 60s maybe Phillips, but who knows. So my guess is this is 50s or 60s vintage. And this thing's still not coming apart, is it? Nope. Okay, well, we're gonna remove those final two screws. There we go. Here, another one. And, oh, the top's coming apart now. Let's pop that apart. And, no, it's still stuck, so we need those bottom ones. Now that's a lot of screws for a little device, but can I say it's mil spec? Gotta have this thing bolted together nicely. Okay, now it's gonna come apart, and off comes the case. So what do we have here? Okay, well, it's a pretty simple device. Inside we've got a stack of wire wound resistors. These are, not sure if you'll be able to see that, but they are 250 ohms each, and they're 5 watts, and they're made in Germany, which is, you know, quite nice. It's the high quality wire wound resistors. I'm not sure that symbol is the manufacturer's mark or not. If anyone recognizes that, let me know. I'd be interested to hear who actually made these. But we've got 250 ohm resistors and we got 5 of them. So that's going to work out to more or less 50 ohms, which is what we want for a 50 ohm dummy load. I'll put that on a meter in a second. We'll take a look at that. I've connected it up with my Kelvin leads, and it's showing a nice 51.2 ohms, which suggests to me that those resistors have been done as they've been selected as a match set. It's also interesting that it's 51.2 ohms because of the fact the old standard was 51.5 ohms before we went to 50 ohms. So there's a possibility that this unit is actually tuned to 51.5 ohms as opposed to 50 ohms. It's not going to make any difference in the work that I do, but it's an interesting tidbit if that's true. I'm just guessing at this point, though. The RF output from the transmitter comes in on this side here, and it goes into this bank of resistors that are all in parallel, and it looks like it's going to, this looks like just a ground point that's grounded out to the chassis, which of course in turn is going to be grounded out to that connector there. So essentially what happens is the RF is going to come in through this side and it's going to be converted into heat, and hopefully on this side there'll be basically nothing left. Here there's a little a wire. See that wire that's bent and goes into the ground point, and that's from the center of the test set port to ground. So I'm thinking that this wire is acting as an antenna. That must be it. So this wire is basically a little antenna that's receiving, you know, the stray RF. There's going to be some in here no matter what. It's picking it up. So based on that, my guess is that this is, you know, a low power test port that I can use for looking at signals that I'm running into this thing. That's actually a huge deal, because what I can do is I can, you know, if I'm working on a transmitter, I can first off, you know, use the standard dummy load functions to confirm the transmitter works. I've also got the meter there, so I can see how much power output it's putting out. And I can connect an oscilloscope or a spectrum analyzer on this side, and I can actually look at the signals that are being transmitted. So I'm going to do that later in this video, I think, and we'll take a look at some signals through that port. That's pretty cool. On this side, we've got a couple of ceramic, they look like ceramic insulators with that's a plastic of some sort. So yeah, it's quite a heavy duty insulator. And we've got a diode here, if you can see that, diode there. And we've got a diode on this side as well. Now the diode goes to the center conductor, right there where the RF is coming in, and it's going through this diode onto this point, this diode. Then there's a wire which goes, oh, there we go, look at that. So the wire's going down to a potentiometer here, and the second wire of the potentiometer appears to go to the meter. So it looks like this is basically a diode RF a rectifier, essentially. It's a rectifier that's converting the RF energy into DC energy in order to drive that meter. And then this potentiometer, that's going to be used to calibrate the meter, so it shows, you know, a relatively accurate wattage up to the 30 watts or 25 watts that those resistors are rated to. So that allows us to adjust that. And yeah, someone's written okay there, which means, you know, it must mean that's totally calibrated. No, I'm just joking there. Okay. Anyways, yeah, so it's pretty basic. You know, essentially just a bunch of resistors there, and input, output, and a detector here to detect the signal so we can analyze it. And then we have a rectifier here driving this meter, showing us what the wattage is. So, I don't know, pretty elegant. Let's take a look at how this thing looks on an oscilloscope. Well, I guess the next step is to plug this thing in and try out this test port and see how it looks on an oscilloscope. So I've got the dummy load hooked up to my test rig, which is a DX959 CB radio. It's connected to the transmitter port, and if I transmit, you'll see the meter goes up, so things are working. Meter's reading 5 watts. It's possible the CB is putting out 5 watts, or it could be that the meter's a little bit out of adjustment. Well, if you're in electronics, you probably know that it doesn't get fun until you pull out the oscilloscope. So I've done just that. I've got the test set output here on the dummy load connected to channel 1 of the scope. Looks like there's a little noise on that. That's fine. A little bit noisy, that's okay. And what I'm going to do is I'm going to transmit with the radio, and we'll take a look at the signal on the scope. Now, I want to check and see what the signal looks like just for curiosity, but I also want to see how much signal there is being induced on this port. And the reason is because I'd also like to check this on my spectrum analyzer, but the problem with the spectrum analyzer is they have a very sensitive front end, and it's very easy to blow them. If you put more than about a volt or so into the front end, you'll blow the meter, and well, you'll blow the front end, and that's a either A, expensive, or B, incredibly involved repair, which I don't want to do. So I'm going to use the much more forgiving oscilloscope. We'll take a look, we'll measure how much voltage it's putting out, and we'll go from there. So transmitting at a 0.5 volt scale, and the screen just goes completely white. It's not good. Bring it to a 1 volt scale, still it's peaking, going from end to end. 2 volt scale, okay, now we can see the size of the signal. If I count my gradients here, I've got something like 1, 2, 3, 4, 5, 5.5. So it's about 10 volts peak to peak on transmit. Now that's way too much power for the spectrum analyzer, so we have a bit of an issue. But now that I think about it, there's an impedance mismatch problem. The 465 scope, it's got a 1 meg impedance on the input, something like that. So we're going to need to match that to 50 ohms. Otherwise, that voltage is going to be completely off. So let's terminate that. We'll use this little T connector here. Like that. Okay, so now this is going to be a 50 ohm load onto 2 volts per division. And look at that, it's much lower. So 1 volt per division, it's looking way better. We've got, you know, less than 1 volt peak to peak. Let's go 0.5, measure that. We've got, what are we going to call that? We're going to call that 0.7 volts peak to peak at 5 watts. And I'm going to take a look at the signal. I'm going to try to get the time right here, see if we can, oh, let's go a little bit smaller. Not triggering. I don't think we're triggering. Are we? No. Come on. There we go. Okay, so there you can see the lovely sine wave output from the AM carrier. And it is 0.2, let's call it, yeah, around about 0.5, 0.6 volts peak to peak for that signal. Okay, well there you have it. Okay, same deal except connected up to the spectrum analyzer this time. I don't need the load on this line because it's a 50 ohm input. And if I click transmit, well, there's a signal over here, but I need to set up the spectrum analyzer first. So let's set the center frequency to 20, center frequency 22.7.0, well, let's just put 27 megahertz. Okay, and then we're going to set the span to 1 megahertz, and let's take a look. There's my signal. So I'm going to adjust my center frequency. Let's go center. I'm going to crank this up a little bit here. Okay, and it's right centered. I can take a look at the frequency. Radio saying 27,365, and if I go and put a peak search, 27,362 according to the spectrum analyzer. So, well, the frequency counter on a CB radio, not necessarily supposed to be the greatest, but at least I know it's a little bit off. I could tune that now, which is great. We'll transmit on AM, we'll take a look at the signal, and we'll see the modulation on both sides of the carrier frequency. So here's the carrier, and if I speak into the mic, there's modulation on both sides of that carrier. Audio, audio. Now, I'll switch it to upper sideband, and we should only see modulation on the upper sideband, or more or less only on the upper sideband. Audio, audio. And we'll go to lower sideband, audio, audio, and you can see the modulations all happening on the lower half of the screen, below that carrier frequency. Also, if I'm not talking, the power output, there's going to be basically no power output on it, so let's take a look. Very low. just that little bit of signal. Whereas on AM, you've got a lot of power on the carrier frequency happening all the time. Now, another thing about CB is, like, you know, if you're using CB, when I was a kid, I would always interfere with the neighbor's TV sets, and it would cause all sorts of problems. And I bet you I can take a look and see why that might be the case. Let's say I'm going to go and increase my span a bit more. What I'll do is I will set my center frequency to 200 megahertz. And then I'm going to set my span to 400 megahertz. And I'm going to transmit, and you can see all these harmonics here. So if I look for my 27 megahertz signal, it's sitting right here. There's that nice signal. But look at this, I've got a harmonic at 55, I've got one at 80. I think this is getting near the TV band for over-the-air analog television. Oh, 108 megahertz, so in the FM band, 107 megahertz. There's tons of harmonics here. And that would be a reason why CB radio would interfere with your neighbors. So, you know, one of the things to resolve that is put a low pass or band pass filter on the output, and that will reduce that. But yeah, if you've got a mismatched antenna, you have a real potential to interfere with other people's analog devices. Not so much a problem in the digital era, but a major issue back in the day. Now I'm going to check the peak power next. So what I'll do is I'll set my marker, peak search, and it is at 1.6 dBm. Marker, yeah, 1.59, 1.6 dBm is what it's saying. Okay, so let's, I can change that to watts on this display here. I'll do that. So let's go, gotta remember how. So now we'll see how many watts are being output there. And if you look, 1.469 milliwatts is what it's saying. Let's make sure my marker's set, peak search. Yeah, 1.469 milliwatts. So not much wattage at all coming out of here. 5 watts in, you know, 1.5 watts out. So I don't know what that's a factor of 3,000 lower. So it's nicely attenuated, and it gives me a nice view of what the radio is doing. Well, there you have it. That's about all I can talk about on a dummy load. Not the world's most exciting electronic device. I hope I didn't put you to sleep. And, you know, if you enjoy these sorts of videos, please subscribe below. I really appreciate all my subs. And, you know, if you want to join up and get more of these videos, you know, please click that subscribe button. It would really mean a lot. Thanks for watching, and catch you next time.